Welcome, Hornets. In this video, we're taking a look at the second part of the particle motion. In our previous video, we talked about how speed was affected. I'd like to now just take a quick look at the velocity and how we can find the maximum acceleration on a velocity. Now, these are where we find points of inflection. So a point of inflection is a change in concavity. So I often refer to it as concave down makes a frown, okay, going down. Concave up makes a cup, okay? And so think about it as a full frown or full smile. So we're looking at a change from concave up to concave down. And this is what we refer to as a point of inflection. Now, a maximum acceleration is at a point of inflection, and we have two of them. We have the maximum increasing acceleration, and we have the maximum decreasing acceleration. Right here we have our point of inflection again. Once again, and that's the location of our maximum acceleration of a particle moving. Now, one of the things that's happening here, and I want you to be aware, is that here we're moving left, as we talked about in the previous video, and right, and left again. We have 2 points of rest position, so particle is at rest. This is because our velocity v of t equals 0. And over here at E, we have another particle at rest. And that's because our velocity v of t equals 0. So you'll notice, similar graph, but if we know where we are and a direction that we're moving, then we can actually determine whether we're moving towards or away from our initial position. Now that makes perfect sense. If I start at a place and I move to the right or to the left, I can then move away from it if I continue moving to the right, being on the right, or I can move towards our initial position by being on the right and moving left. The contrary is also true, where if I am on the left side and I move to the right, I have to be moving to my initial position. And if I have moved to the left of my initial position and I continue moving left, I move away. So this is our basic idea that we're talking about when we think about moving towards or away from the origin. Towards or away from the origin. Now, once again, keep in mind that we have two conditions. If the position and velocity are both positive, therefore have the same sign, because this would also work for being negative. We say that the particle is moving away from the origin. If the position and velocity have opposite signs, then the particle is moving towards. Now, if you think about it, what we're talking about is an increasing and decreasing distance. Now, before, in the previous video, we were talking about increasing and decreasing speed. And when I had an increasing speed, I had the velocity and the acceleration having the same sign. Well, now we're talking about the distance between the origin and the particle. And that's going to be growing if position and velocity have the same sign. Now, keep in mind that that would mean then, just like we saw with speed decreases when we have the velocity and the acceleration having opposite signs. We now have the distance between the particle and the origin decreasing when the position and the velocity have opposite signs. Okay, so that's really what we have until we start talking about integration. Because when we talk about integration, we can now determine, well, am I further to the right or further to the left? Okay, and we start combining our absolute maximum with our relative maximum when we start working with these. Alrighty, thank you very much, Hornets, and we will continue with the first derivative test in our next video. Thank you very much. Be well, be safe.